Hi, my name is Mark Lajeunesse and welcome to Hard-Boiled Synthesis, Lecture 21. Today, we are continuing our analysis phase. If you're just catching up, there are many lectures for you to look at. But today I feel like it's going to be straightforward. I am just going to do a multi-factor meta-analysis. That's a mouthful. But you'll see that I'm using it in a way to just kind of make sure that some of my previous analyses are okay. Now, if you're not familiar with multi-factor meta-analysis, I would suggest you read up on the multiple regression literature. That is really the best way to start understanding these types of analyses, where I'm including more than just one factor in a model. I'm including multiple factors, and that literature is abundant, easy to find, especially for R. All that stuff applies to what I'm going to do today. None of it is really different for meta-analysis. And so if you could just prime yourself with that lit before you start doing more complex modeling, you'll save yourself a lot of trouble. The unfortunate part is with meta-analysis in R, things aren't quite as straightforward as they should be, especially if you're more comfortable reading effects tables rather than regression coefficients. But I'll go through a little bit of that today. Again, my goal is just to really answer one question today, and I'll be able to do this with the multiple meta-analysis model here. I'm nervous that some mosquitoes are responding differently depending on the formulation of catnip. I found that different mosquito species differ in terms of efficacy of catnip relative to DEET. And I found that the formulation of catnip helps predict whether or not it's an effective repellent relative to DEET. And so maybe there's I analyze these two factors separately. Let's throw them together in a model to see if they relate to one another. If they do, that's a real bummer because it makes things way more complicated. Like, I really do not want to spend time explaining why a single mosquito species can respond differently to catnip oil versus some of the more active compounds, the isolated active compounds. If there's a mosquito that responds differently based on these two things, I don't know how to explain that biologically, really. And so if I could protect myself from taking the project to that stage by doing these multi-factor analyses, I feel like I'm ready to start pulling together the manuscript. In the next lecture, I'll actually compare and contrast some of the issues associated with my effect sizes. I know they're not as clean as they should be. There's certainly outliers. I haven't explored publication bias yet. If you're reminded from a previous lecture, I kind of did all this backwards. And so I still have to do that. That's still on my to-do list. But today I just want to, cast a safety net to make sure that it's okay for me to present things in a univariate way. Now, aspirationally, you should try to do the full multi-factor model with your data set. Include all the predictors, including their interaction effects. That would really be the best way to understand how all these moderators work together in predicting effects. In my case, that's not so interesting to do because all my predictors are experimental, right? Different experimental designs, different ways to formulate catnip. But in some disciplines like ecology, you have competing predictors, competing hypotheses in what should explain variation in outcomes. And so the best way to approach that is to actually have a nice, fully parameterized model that includes all the factors. The benefits of that is you see how they relate to one another. You could determine which are more useful in predicting effects. Lots of neat stuff you could do. The trade-off, however, is you need complete cases to be able to formulate, to be able to build that linear model. And so every time you're missing information of a predictor, that entire row of data gets dropped from the full model. And the more predictors you include in the model, each predictor has a varying degree of missingness, right? Things you could not extract from the paper. Those things add up, and you end up dropping many, many, many rows in your data set to achieve this full multiple regression style meta-analysis. I think that's why conventionally meta-analysts, at least in ecology, report things in a single factor univariate way, just so that they could make use of all the data that they've collected. But again, aspirationally, you should try to do the whole complete model. I mean, that's really the best way to understand how all these things interact and impact and predict. If you want to create a really robust predictive model, you really need to include all these things in a single lens. So today, really, this is the question I want to ask. Do different mosquito species, I'm going to say different many times now, do different mosquito species respond differently to different formulations of repellents, right? Worst case scenario, a single mosquito is repelled differently with catnip oil versus the isolated active compounds. I mean, that would just be super weird. And that could happen because I have so few effects per species. I mean, that's the real bummer here, is like I have a lot of replication. There's a fairly decent amount of studies, but when you parse it by species, man, you're really just limiting yourself to few effects per group. You lose a lot of power in assessing differences, and you open yourself up to sampling error because you have few replicates per group. Anyway, so again, I'm going to jump into R. Hopefully everything's going to work nice today. Just to catch you up, I got my R script right here. Package metaphor is already loaded. You know, it's the heavy lifter of meta-analysis stats. In R, I got my catnip data set, which is only including the contrasts between catnip and DEET. And then I got my regression model here. So I'll just call it model for model. And right now it's just doing a grand mean across all the effects, right? This is I don't know why I didn't clean this up before for you guys. So this is the main model. It's just doing a grand mean across all effects. I got about 128 in the data set. So hypothetically, if I run this now, it's just going to give me a giant average. Giant average right here, which is overall indicating that catnip repels mosquitoes similarly to DEET. But again, I don't have high confidence with that conclusion, because we found that there's many predictors that could moderate this overall effect. So my goal now is to make sure that two of these predictors don't interact, so that I could keep things simple in my analyses in terms of describing effects. I really do not want to describe individual effects per species. That would be a mess. All right, so we're going to slowly build the model, starting with mosquito species. And so now the meta-analysis model includes this this categorical factor, which parses all of these effects into the different species of mosquitoes. And let's just run that. And so here the way R presents a regression coefficients is that the intercept is the reference value. It's normally the first. There's like an alphanumeric sorting that goes on amongst the categorical groupings. And the intercept becomes the first member of that sort. And so in this case, I really don't know what species. I guess I could quickly figure it out. Factors, and then I want levels of that. Right now, I'm just trying to figure out what is the order of all these categorical groups. All right, so everything is relative, it looks like, to Aedes aegypti. All right, so all these regression coefficients right here, the intercept here means Aedes aegypti. Okay, and so everything that follows is a contrast relative to that mosquito species. So really you're asking the question is Aedes albopictus the effects of catnip are, gets really complicated in terms of interpretation. Aedes albopictus mosquitoes, are they responding differently or responding less than Aedes aegypti in terms of repellency of catnip relative to DEET? Oof, there's just like so many dimensions to this. It's getting pretty silly. Okay, so you would conclude that, oh, okay, there's no difference between Aedes albopictus and Aedes aegypti. Okay, but there is a difference with Aedes cretinus and Aedes vigilax relative to Aedes aegypti. Okay, and so this is kind of useful if you want to make comparisons between species. This model here in particular is testing whether or not there's a difference amongst mosquito species. It's an omnibus test. The QM here, if you go back to the original ANOVA style meta-analysis models, we will call this QB, Q between test. Here we have Q moderator test, or QM, for the number of groupings that you want to compare. It says here with degrees of freedom of 11, means we have 12 groups, 12 categories. There is a somewhere in there, there's a pairwise difference between the species. And you could actually see it here. There's like a whole load of species of mosquito that differ from Aedes aegypti. And so this is the test that provides, the omnibus test that provides that conclusion. Now you could remove the intercept of the model if you want to just see all the averages within each species. There's different ways to get those averages between species. This is what you would plot. So like in the previous analyses, you know, this is what I plotted, was the averages at the species level. And so here, by removing the intercept, now we have the regression coefficients presented in a way where we have all our means, all our average effects organized at the species level. And so we have 12 species, and then we can see the direction and magnitude of how catnip is an effective repellent. And it's all over the place. I mean, there's some negative effects, there's positive effects. And so this is what I'm kind of concerned with, is maybe the positive and negative effects change depending on the formulation of catnip. Maybe Aedes aegypti responds differently from if you use essential oils compared to the more pure formulations just using the meta-lactone, right? The isolated active compound from catnip. And so now we're just going to build a model that includes these formulations of catnip to assess whether or not you have this difference that occurs within species. Oh yeah, just an aside, you know, another way to drop the intercept from the model to get to all the average effect sizes per group in your categorical model, you know, you could drop it this way by removing one, but you could also, you know, do this. Just say there's no intercept plus the categorical group, and this should provide the exact same result. Sometimes I like to do it this way when I'm teaching it because you know, you're building a model as opposed to excluding factors in a model. And you'll see with like multiple regression practices, you could build models and you could start removing things from the model depending on how you write the linear model formula in R. I'm going to try to keep it consistent here and always have the full model. Okay, so my goal now is to test whether or not there's an issue between the mosquitoes and the formulation of the catnip. I'm going to build the model. I'm going to include repellent class, which is the categories essential oil, meta-lactone, and then others. And then I want to include whether or not there's an interaction between the two, whether or not they, in the presence of the other, the effect changes. That's essentially what an interaction effect is. And the way you do that in R is you link them together with this. And so here we have our fully written out linear model with the main effects of mosquito species, repellent class, and then their interactions. And if I run this, everything's going to be presented again in terms of regression coefficients. It's going to be difficult to interpret because, again, everything is associated with the reference value. But I'll quickly, because all I'm concerned is testing whether or not there's an interaction effect, we're going to just slightly modify the model to test that effect. So if I did this right and I run the code, we're going to get a mess of stuff. We got our intercept again. We got all our mosquito main effects. We got our repellent regression coefficients. And then finally we got our interaction regression coefficients. And it looks like there are very few opportunities to do a full interaction effect between the different repellent formulations. So it just means that for a lot of the mosquito species, we just had one or the other and not both. So the three species where we had enough information for the two was Aedes cretinus, Culex pipiens, and Culex quinca fasciatus. Oof. I always have challenges pronouncing that mosquito. And because things are so broad here, right, the table spilled over, and it looks like there's some evidence right here, which is the p-value of the z-score of the regression coefficient, that there's something going on in terms of interactions. But this is not a proper interaction effect test. I'm not concerned with individual effects here. All I want to know is, in the presence of the formulations of catnip oil, does it modify repellency effects among mosquitoes? And so now this is going to be a really simple thing. Oh no, I got an issue here. Let me look it up here. I got an issue. Okay, slight technical issue. Oh, it's just, you know, the setup I got is a real bummer sometimes. Come on. I'm sure you guys are really excited about my technical problems. Okay, I think I got it. Okay, I just totally lost track of what's going on here. And so I got to fully parameterize multiple regression style model, including the two factors, mosquito species, repellent class, and the interaction between the two. I just want to test whether or not there's the presence of an interaction effect. This would be a worst case scenario for me in terms of understanding what's occurring biologically with catnip. If I could avoid that entire discussion, that would be an amazing thing. And so my goal now is just to provide some confidence to me that I could move on with my univariate tests. All right, so how do you test whether or not there's an interaction occurring when you have multiple factors? And ANOVA is one of these functions that is very flexible. It allows you to include, exclude factors. It allows you to build models. In my case, I want to keep things fairly simple, and I'm going to include my model output in here, and then I'm going to do my interaction test. And what I'm going to do is I'm going to collect all the regression coefficients that report an interaction. So these three right here. And then I'm going to test whether or not together they equal 0. Another kind of omnibus test. So this is akin to a lot of these main effects, classic main effects analyses that you would see in old textbooks when you would do a ANOVA style analyses. You'd have your main factor, secondary main factor, other predictor, and then you have the interaction between the two. You would only have 3 things to report. You wouldn't report this giant morass of regression coefficients. And so now I want to basically assess whether or not these coefficients are equal to 0. And if they are, I could take a nap. I could take a nap, and then we could start actually pulling together the manuscript. If not, I mean, this whole project is a disaster because there's complications here that I should not be spending a lot of time working on. Okay, so now I'm just going to combine these regression coefficients into a single test to see whether or not together they differ from 0, and if they don't, I'm good. No interaction effects, maybe providing some really loosey-goosey justification for why I could keep these factors separate in my description of the meta-analysis. And the way you do that is you use this BTT. I should look up what BTT means. I don't know. All I know is it allows me to group things and allows me to test the main effects without having to do, without actually having to modify the model or to build multiple models to test the effects, which is an alternative way to test for interactions. But I need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right, so I'm telling it now, hey, combine 15, 16, 17 and assess whether or not they differ from 0. This is essentially my interaction main effects test. And let me just clean up this stuff. All right, this is it. So much talking just for just this one line. Okay, so we have our QM here, which is now designed in a way to test for an interaction effect. And it says that there's no evidence to conclude that these things do not differ from 0. And so to me, okay, I'm excited. It means I don't have to worry so much that there's some weird differences in mosquito behavior relative to which formulation of catnip that they're exposed to. I mean, that would just be the worst case scenario for me to describe, because I wouldn't know. I don't know. Why would Aedes aegypti differ if you expose it to an essential oil versus a pure compound? That would just be bizarre. So now I don't need to even think about that complexity in my analyses, and I can move on. And so just to conclude, right, I'm using multi-factor, multiple regression style approaches for meta-analysis so that I could evaluate whether or not my moderators relate to one another. Conventionally, many people just report moderators separately, but I like to go a step further, and aspirationally, you should try to also go a step further and build more complicated models. That truly is one of these things that's kind of underused in meta-analysis, is building these large predictive models to try to evaluate, tease apart what is the most interesting or best things that predict the effects, the study outcomes. All right, I talked a lot just for just this one analysis. Next step for me in terms of analyses is simply going to be doing publication bias stuff and evaluating outliers, sensitivity analyses. So that's all I got for today. And take it easy, friends.